Now, this video deals with a challenging topic, so that's just the first thing I need to say. This topic is challenging, but it's easy. But it's one of those topics in maths which makes sense after you've practiced. So if you don't get the procedure the first time, wait till the second example. By the second example, you should have a better understanding. And by the third example, it should be essentially understood. And all you just need to do is you just need to do some more practice on your own. So this is one of those kind of topics. So back to the topic, we're solving a quadratic equation using a related equation. So let's just look at the first part of this topic, solving a quadratic equation. When you solve a quadratic equation, so an equation of this form, where a is not 0, you get solutions. So you get x equals something and x equals something. Sometimes you get two solutions. So you get x equals x1 and x equals x2, where x1 and x2 are just solutions. So that's what you do. That's what you get when you solve quadratic equations. And we have some methods we've already used for solving quadratic equations. We use the quadratic formula, also known as the almighty formula. We use the method of completing the square. We even use the method of inspection. But now we're going to use a different approach, a graphical approach. So we're going to use a related equation to solve a given quadratic equation. So what does that mean? So here's a question. So this is best understood by demonstration. Question says, or the problem statement is, using the graph of y equals x squared plus 5x plus 6 given below. So this red curve has the equation. Basically this red curve is the plot of y equals x squared plus 5x plus 6. This red curve here has this equation. Now it's saying, using this graph, solve the equation x squared plus 5x plus 4 equals 0. Now the whole idea of the topic is that you need to solve a quadratic equation. Now we're solving this. This is what they want us to solve. But you need to use a related equation. And they're telling us to use the graph of this equation. How are they related? Well, let's write the equation of the graph. Y equals x squared plus 5x plus 6. And the equation we're solving is x squared plus 5x plus 4 equals 0, which is the same thing as 0 is equal to x squared plus 5x plus 4 if you just swap the left and right hand side of this equation. Now as you can see, these two equations are similar, and that's where the whole related thing comes from, because not necessarily because they're similar, but because these two equations can be related to each other. How? Well, here's the procedure. So you're asked to solve this equation, and it looks similar to the equation of the given graph, but this is the equation you're asked to solve. So do not confuse it with the equation of the graph. Now the first step, there are 4 steps, and I've outlined the 4 steps here, so I'm just going to read through. The first step is to rewrite the equation of the given graph, so that y lies on the right hand side. Now where's our graph? The equation of our graph is y equals x squared plus 5x plus 6. As you can see, y lies on the left hand side. So the first step is to rewrite the equation of the graph so that y lies on the right hand side. So this equation of the graph, in order to have y lying on the right hand side, what you can just take y to the right hand side, or do what this step says, which says just swap the left hand side and the right hand side. And that's what I've done here. So that's the first step. The first step says take the equation of the graph and just swap the left position of the left hand side and right hand side. That's very easy to do. So that's the first step. Easy. Y equals x squared plus 5x plus 6 becomes x squared plus 5x plus 6 equals y. The left hand side and the right hand side have been swapped. Let me use a different color here. So we're moving on to step 2. Step 2 says rewrite or modify, same thing, the equation whose solution is required. So we're trying to solve the equation x squared plus 4x. In fact, here's the equation here. We're trying to solve this equation, x squared plus 5x plus 4 equals 0. Now rewrite or modify the equation so that its left hand side is exactly the same as the left hand side of the rewritten equation of the given graph. Basically, rewrite this equation so that its left hand side, this is the same as this left hand side here. And the way to do that is, by inspection here, if I add 2 to both sides, I'm going to get a left hand side here that's equal to this left hand side. So x squared plus 5x plus 4 equals 0 is the equation. If I add 2 to both sides, adding 2 to the left hand side gives x squared plus 5x plus 4 plus 2. So this is the left hand side, and that's the same thing here. I'm adding 2. This is our right hand side, and I'm adding 2, and that gives x squared plus 5x plus 6 equals 2. And the left hand side now is the same as the left hand side of this equation, which I'm going to call 1. So that's step 2. Step 3 says write down equation 1, which is this, and equation 3, which is this one. Write them next to each other and equate the right hand sides. Doing so is basically saying that y is equal to 2. And you get an equation. I'm going to call this equation 4. That's step 3. Equating the right hand sides of equation 1 and 3. Now step 4 just requires you to plot the equation 4. In this case, we're going to plot the graph of y equals 2 on the given graph. So here's the plot of y equals 2, this blue line here. Y equals 2 is this blue line here. You can see y equals 2. Now, the solution to the equation we're trying to solve is given by the x coordinates of the point of intersection of the two lines. And we can read off that the x coordinates of the first point, point A, is -4. The x coordinates of the second point, point B, is -1. And we are done. So the solutions to the equation we are trying to solve. Go back to the question. We also solve this equation. Solutions are x equals -4 and x equals -1, according to what we got here. So now I don't expect to have understood everything I've said, but just let's review everything now. So we're given a graph y equals x squared plus 5x plus 6. That's this red curve here. I also solve this equation. Now we follow the steps and we go to the point, the last step, and second to the last step, the last step, which step 4, which says plot some certain equation. For this example, the equation we had to plot was y equals 2. And all we had to do was locate the point of intersection and read off the x coordinates, and that's all. So solving a quadratic equation using a related equation is very simple, because you just be given a quadratic graph. All you have to do is plot some equation which you determine it's the point of intersection of the two graphs you have, and just read off the x coordinates. So it's as simple as that, but there's some certain steps and procedures you have to follow. So we're going to look at another example, and after this you should have a better understanding. Then we're going to look at a third example. Here's another example. So you're required to solve the equation 3x squared minus 3x minus 18 equals 0. You need to solve this equation, but you are required to use the graph of this equation, and that graph is given here. So we need to follow the steps. So just to outline, just to kind of focus on the key things, we're required to solve this equation. We need to solve this, and this is the equation of the given graph. That's the equation of the given graph. So now we apply step 1. Step 1 says take the equation of the given graph and rewrite it so that y is on the right hand side by swapping the left hand side and right hand side. So step 1 is very easy. The equation of the given graph, just swap the left hand side and right hand side. So doing that gives me 3x squared minus 2x minus 10 equals y. I'm going to call this equation 1. So that's step 1. We have 3 more steps. We're almost there. Step 2 says take the equation required to solve, which is 3x squared minus 3x minus 18 equals 0, and rewrite this equation so that its left hand side, which involves all the x terms, is the same thing as the left hand side of equation 1. So how can you do that? Well, there must be something I can add to the left hand side of this equation, which will give this right hand side here. But I must also do the same thing. If I add something to this left hand side, I must also add something to the right hand side. So this gives me 0 plus alpha. So I need to now find out what this alpha is, because when I add this alpha to this left hand side, and obviously to the right hand side, I get what I'm looking for in step 2. I get a left hand side which is the same as this. So first of all, let's find alpha. So what we're saying is this left hand side term plus alpha, this plus alpha, must be equal to this. So I'm going to use a different color to state that. That's what 3x squared minus 3x minus 18 plus alpha. So this must be equal to this left hand side term. So what we can do is just put all the terms on one side. So I'm going to subtract 3x squared from both sides. I'm going to add 3x to both sides, and I'm going to add 18 to both sides, because I want to make alpha the subject of the formula. So doing that gives the following. So that's what happens when you subtract 3x squared from both sides. When you add 3x to both sides, you get this, and when you add 18 to both sides, you get this. This gives alpha is equal to 3x squared minus 3x squared is 0, minus 2x plus 3x is x plus x, minus 10 plus 18 is 8. Therefore, alpha is x plus 8. So when I add, this is the equation required to solve. If I add x plus 8 to both sides, I get a left hand side that looks exactly like this. So I have 3x squared minus 3x minus 18 minus 3x minus 18 plus alpha, which is x plus 8, is equal to alpha. So let me just restate what I just did. So this is the first step. Step 1 was easily understood. In step 2, all we had to do was rewrite the left hand side of this equation so that it matched exactly with this left hand side. And in order to do that, I said, well, we have to add some term to this left hand side. But if I add a term to the left hand side, I must also add the same term to the right hand side. Now this term I add to the left hand side is such that it gives a whole left hand side that's equal to this left hand side. So this must equal that when I add alpha. So I now found the alpha value, which is x plus 8. Now let's test it. Let's simplify this left hand side. We have 3x squared, so I'm going to group like terms, minus 3x plus x minus 18 plus 8. Right hand side is just here. So I'm just going to simplify the left hand side. Just give 3x squared minus 2x minus 18 plus 8 is minus 10. I'm going to call this equation 3. Now, the left hand side is 3x squared minus 2x minus 10. And that's the same as the left hand side of our graph. So the next step, step 3, is to equate the right hand side of equation 1 and equation 3, where equation 3 is the equation where the converting equation that has the same left hand side as the equation of the graph. So equating the right hand side terms, right hand side term of equation 1 is y, the right hand side of equation 3 is x plus 8. That's what we have. So step 4 just says plot y equals x plus 8 on this graph. Plot it here, and all you have to do is, to get the solution, is to read off the x coordinates of their point of intersection. Now that's what I've done here. I've plotted y equals x plus 8, so that's this line here. So the red curve is the original graph we got, and this blue line here is y equals x plus 8. We plotted y equals x plus 8 because that was the equation we got in step 3. The point of intersection, a and b, have x coordinates minus 2 and 3. Therefore, the solution to the equation we are asked to solve, this equation. The solutions are x equals minus 2 and 3. 3. So those are the solutions. So now you've seen another demonstration of the method, but this time I added something slightly different because we had to find the term you could add to this left hand side to make it equal to this left hand side. That wasn't done in the first example because we could easily tell what alpha was by inspection. But in this case, we had to find what alpha was, and we found that alpha was actually x plus 8. And when we tested it, we could see that the left hand side became 3x squared minus 2x minus 10, which is what we wanted. Then we equated the right hand side of equation 1 and equation 3, the converted equation. And we got the equation y equals x plus 8, which we then plotted. And we read off the coordinates of the point of intersection of the line we plotted and the curve. And we got x equals minus 2 and x equals 3 as the solutions to the quadratic equation we were asked to solve. So this is just the second demonstration. Let's go for another one. Here's another example question. In this example, we're required to solve this equation. So we need to solve this using the graph of this equation. So this is the equation of the graph. And this graph is this red curve here. As you can see, y equals 3x squared plus 6x minus 3. That's this here. Now when you have this type of problems where you're solving an equation using the equation of a given graph, first step, take the equation of the given graph. Rewrite it so that y lies on the right hand side by swapping the left and right hand side terms. Doing so gives this. And that's the end of step 1. So we're going to call this equation 1. That's the end of step 1. Step 2 says, take the equation you're required to solve and rewrite it so that the left hand side term is equal to the left hand side term of equation 1. So I'm going to modify this equation by adding alpha to the left hand side. When I add this alpha, alpha is an unknown, to this left hand side, this whole term is going to be this. Now for this equation, if I add alpha to the left hand side, I must also add alpha to the right hand side. Whatever I do to the left hand side of the equation, I must also do to the right hand side. Now what is this alpha? Alpha is such that adding alpha to this, so i.e. this expression, adding alpha to this expression gives this, and it's such that this expression is equal to this. We're trying to make this left hand side equal to this left hand side, and we do that by adding alpha to this left hand side. So we're saying this, when I add alpha, this whole thing becomes this. So we simplify, make alpha the subject of the formula because we're looking for alpha now. So I'm going to subtract 3x squared from both sides, and that gives 5x minus 4 plus 4 equals 6x minus 3. Next I'm going to subtract 5x from both sides. That gives a minus 4 plus alpha equals 6x minus 5x minus 3. Next I'm going to add 4 to both sides, and it gives alpha is equal to 6x minus 5x minus 3 plus 4, which gives alpha is equal to x plus 1. So when I add x plus 1 to the left hand side and right side of this equation, well, when I add x plus 1 to the left hand side of this equation, it becomes equal to the left hand side of equation 1. And let's test it. So this is the equation here we are required to solve. If I add x plus 1 to the left hand side and obviously to the right hand side, let's see what we get. Well, we have 5x minus 4. I'm dropping the brackets, x plus 1. I'm just going to simplify the left hand side. This gives 3x squared plus 5x plus x, 6x minus 4 plus 1 is minus 3. Now this 3x squared plus 6x minus 3 should be equal to the left hand side of equation 1. It is. So now we've modified this equation to give this, and this equation we obtained, I'll call this equation 2, is such that its left hand side is the same as the left hand side of equation 1. So we move on to step 3. To avoid confusion and to be consistent with the first example, I'm just going to call this equation 3, and equation 2 will be the equation you're required to solve. So this should be the equation from step 2. That first equation should be equation 2. So just to be consistent. So step 3 says take equation 1, which is this, and take equation 3 and write them side by side and equate their right hand side terms. Equate y and x plus 1. And doing that gives this equation. Remember, equation 1 is this. And then the final step, step 4, says plot this equation on the same graph paper that contains the curve that's given, the graph that's given, and find the point of intersection and read of the coordinates. So we're plotting y equals x plus 1, point of intersection a here and b, and we just read of the x coordinates of the point of intersection. The x coordinate of point A, one of the points of intersection, is minus 2.26. The x coordinate of point B, the other point of intersection, is 0.59. So these are the solutions to the equation we're required to solve this equation. So now we've actually gone through the procedure 3 times, and I'm pretty sure that at the end of this third example you must have a better understanding than you did when you looked at the first one. But to fully master this, you need to practice, you need to do more practice, and eventually become second nature to you. So do just practice.